What if I told you that a particle can exist in two different places at the same time, pass through a wall without ever breaking it, and remain mysteriously connected to another particle on the other side of the universe? That's coming up in Quantum Dracarys. As strange as these ideas sound, they are part of one of the most successful scientific theories ever created, which is of course quantum mechanics. So what's quantum mechanics and how it was started in the first place? So I think in order to have a clear understanding of something, it's better to go back in history and check how that thing was started in the first place. In this video, I will try to show you how the first theory of quantum mechanics was born and the theories that came after that. By the end of this video, I hope you will have a clear understanding of what's quantum mechanics and how it was born. At the end of 19th century, physicists were extremely confident. Newton's law explained motion, Maxwell's equation explained electricity, magnetism, and light. Scientists believed they were close to understanding almost everything about nature. Some even thought physics was nearly complete. But then, something strange happened. A problem involving something as ordinary as a glowing piece of metal. Imagine heating a piece of iron. As it gets hotter, it changes color. First red, then orange, then at a very high temperature, it can appear almost white. Scientists wanted to understand exactly how hot objects emit light, or in what way they emit light. Classical physics, they calculated what should happen, but the prediction was a disaster. The equations suggested that hot objects should emit an infinite amount of ultraviolet light. Obviously, that doesn't happen. This contradiction became known as the Ultraviolet Catastrophe. I'll make a separate video explaining the Ultraviolet Catastrophe in more detail, so make sure to subscribe if you don't want to miss it. Because of this Ultraviolet Catastrophe, classical physics had failed, and nobody knew why. In 1900, a German physicist named Max Planck proposed something radical. What if energy isn't emitted continuously at all? What if nature releases energy in a tiny discrete packets? Planck called these packets quanta. At first, even Planck considered this idea a mathematical trick. But it worked. The theory perfectly matched the experimental results. Without realizing it, Planck had opened the door to an entirely new understanding of reality. Today, we call them photons. This idea explained a mysterious phenomena known as the photoelectric effect. For this work, Einstein later received the Nobel Prize. But here is the interesting part. Ironically, the same man who helped create quantum mechanics would later become one of its biggest critics. Weird, right? But that's a story for another video. Over the following decades, scientists such as Niels Bohr, Louis B. Broglie, Erwin Schrödinger, and Werner Heisenberg developed the theory now we call quantum mechanics. Their discoveries revealed a world unlike anything people had imagined. A world where particles behave like waves, where probabilities replace certainty, and where observation itself seems to play a mysterious role. The deeper scientists looked into nature, the stranger the reality became. So what's quantum mechanics, right? So quantum mechanics is a branch of physics that describes how nature behaves at the smallest scales. It explains the behavior of atoms, electrons, photons, protons, and the fundamental particles that make up our universe. Without quantum mechanics, we wouldn't have a modern computers, lasers, semiconductors, or much of the today's technology. It's one of the most accurate scientific theories ever developed, and yet it remains one of the most mysterious. In future videos, we will explore the experiments, the ideas, and the discoveries that built modern quantum mechanics. Until next time, keep questioning reality, stay tuned, and subscribe Quantum Dracarys.